Hello dear students, I am Dr. Shikha Pandey, Associate Professor from Institute of Aeronautical Engineering. Today I will discuss about the topic that is pre-treatment and co-digestion for the enhancement of biogas production. So for the enhancement of biogas production, what are the pre-treatment and co-digestion process will be required for the live feedstock and the waste that are going to be put inside the reactor chamber. Okay, so this will be the whole picture of this municipal solid waste management. Here what happened, from waste generation to waste handling will be there, and we have already discussed about the waste generation. It's a primary collection and it's a handling, storage, and the secondary collection also. And then what happened, transfer and transport of this municipal solid waste, and then processing and transformation. So here we are at this point. So in this, that's why we are discussing this co-digestion. So what are the pre-treatment should be required for this municipal solid waste before going for the disposal. So the transformation of waste from one form to another form. Transformation will lead toward the conversion of waste from a toxic form to another useful form. So this transformation will be act like a we have discussed about the anaerobic digestion process. Anaerobic digestion process will lead toward the decomposition of microbial activity that is going to be degraded and the organic matter present in the solid waste. So this organic matter will decompose by the microbial activity in the absence of oxygen condition. Then finally it will lead toward the disposal of this solid waste. So what is this pre-treatment? First we'll discuss about the pre-treatment. Pre-treatment is like a process of initiating or improving the efficiency of microbial attack on a substrate. So substrate will be there, the biomass will be there. So pre-treatment is a process that will be like, it will be going to initiate or improve the efficiency of microbial attacks on the substrate. So during the pre-treatment process, the compact structure of biomass is disrupted and exposed to microbial attack. So during this pre-treatment process, what happened? The compact structure of biomass will be there. This will be disturbed and exposed to microbial attack. So pre-treatment process will be of three types, like a physical process, chemical process, and biological process. Physical process will lead towards the comminution or irradiation. Chemical is like some alkali treatment will be there, some acid treatment will be there, or some wet oxidation treatment will be there. Likewise, for the biological pre-treatment, some fungi and enzymes will be there. So here three type of treatment will be there, that is physical, chemical, and biological. Physical will be like comminution and some irradiation will be given. Like chemical will be like some alkali treatment or some acid treatment or some wet oxidation treatment is there. Or for biological, some fungi and enzyme treatment will be there. So this pre-treatment technology is going to ensure that the biomass disintegration and improved solubilization in order to overcome the biological limitation of anaerobic digestion. So the pre-treatment technology is basically ensures the biomass disintegration and improve solubilization in order to overcome the biological limitation of organic digestion. So it will be supporting or it will be disintegrating the biomass and improving the solubilization of the solid waste. So this solubilization will going to overcome the biological limitation of anaerobic digestion. So through the pre-treatment of any substrate like that is present in the anaerobic digestion chamber, not only the biogas, but it will be increased the calorific value, higher calorific value of the gas, and it can be obtained leading to less efforts in purification for biomethane production. So through pre-treatment, what happened? Any substrate will be there, not only biogas yield but can be increased, and also higher calorific value of the gas can be obtained. So higher calorific value of the gas will be obtained because when we will give the pre-treatment of the substrate, the materials we are putting into the anaerobic digestion chamber, so if it will be on a proper Pretreatment will be given to this substrate, then it will be having the gases we are obtaining from this anaerobic digestion chamber will be having high calorific value of the gas, and it can be leads to the less effort in the purification for the biomethane production. So it will be going to be very less effort for the biomethane production. Basically, what we'll do by this anaerobic digestion chambers, we will extract from by anaerobic method, we will extract biogas. And biogas is what it is, a composition or mixture of methane. So this when we will do pre-treatment of the substrate, pre-treatment of substrate means pre-treatment will leads towards the production of high calorific value gas. If pre-treatment will be done for the substrate, then the gases will be having high calorific value. Substrate will be having high calorific value, and it will be leads toward the less effort for the purification for biomethane production. It will be leads towards the very less effort will be required for the purification of biomethane production. So why this pre-treatment are necessary? This pre-treatment is necessary when the biodegradable and solid organic material is unavailable, and it will be leading to lower digestion rate. So what happen? Radially biodegradable and solid organic matter will be unavailable, means it will be not there, and the organic matter will be not radially soluble, not radially biodegradable. Then it will be leads toward the lower digestion rate, and the rate of hydrolysis through conventional anaerobic digestion is lower, resulting in the higher HRT. So the rate of hydrolysis, the hydrolysis rate through conventional anaerobic digestion is lower, and that is going to be results in the higher HRT of digester and the largest digester capacity or the volume. And next is the lower biogas yield. So these are the points. This will make this pre-treatment necessary. Pre-treatment is necessary because of the reason like the radially biodegradable and solid organic matter is unavailable. It will be not available. So if it will be not available, then it will lead toward the lower digestion rate. So it will be takes towards the lower digestion rate. Next is the rate of hydrolysis. Hydrolysis, like this rate through conventional anaerobic digestion method is lower, and that will be results in the high HRT, high hydraulic retention time of the digester, and the largest digester capacity or some largest volume capacity digester. Next is it will lower the biogas yield. So these three are the important point. Because of that reason, the pre-treatment is very much necessary, and this pre-treatment is required. So next we'll discuss about the effects of pre-treatment on different type of substrate. So there are various type of substrate which biogas can be produced. First is the lignocellulose substrate, then crop residue, then energy crops. So all these residues are there, like some energy crop residue, some crop residue will be there. There are sometimes some lignocellulosic substrate will be there. So all are like either the residue from crops, or the residue from energy crops, or the crop biomass, like if maize will be there, if wheat will be there, barley will be there. These are some crops. These crops can be act as a feedstock inside the anaerobic chamber. So the lignocellulose substrate will be there. That will be like crop biomass. So crop biomass is like, first is the crop residues and energy crops will be there. So these are some of the types of substrate that can be basically used in the biogas, and it will be produced. Some of them are, this is the examples. Okay. For energy crop, what are the energy crop we are using? First is the sunflower crop and oilseed rape crop. So this is a mustard field, and mustard field is there. Mustard field, and this is the sunflower field. Both are like acting are the energy crop for this feedstock. So all these are given to the biogas chamber for this anaerobic digestion process. So effects of pre-treatment of lignocellulosic substance. So the substance which are in the lignocellulosic substrate will be there. So this lignocellulosic biomass has a very diverse composition and a very complex structure, which is resistance to deconstruction of microbial activity. So these two lignocellulosic biomass has a diverse composition and a very complex structure. This will be a resistance to the deconstruction of microbial degradation. So this lignocellulosic biomass is a very complex composition is there, and that complex structure will leads to a resistance to the deconstruction or the microbial degradation. Next point is the cellulose and hemicellulose are there. They are polysaccharide and that can be hydrolyzed to simple sugar. Cellulose and hemicellulose are there and some polysaccharides are there. So they can be going for the hydrolysis process to a simplest sugar. All are breakdown, these cellulose, hemicellulose, polysaccharide. So these all are breakdown into its smaller unit. So that smaller unit is called as a simplest unit of sugar. Next is what happened. Lignin supports will be there. The lignin supports the cell structure in embedding cellulose and hemicellulose. This supports the cell structure, and this cell structure is made up of by embedding cellulose and hemicellulose. So hindering the susceptibility of microbial attack during hydrolysis process of anaerobic digestion. And the pretreatment will break the lignin layer, making the biomass more susceptible to the microbes. So this pretreatment will break the lignin layer and making the biomass more susceptible to the microbes. And the cellulose and hemicellulose are basically polysaccharide. This polysaccharide can be hydrolyzed to a simplest sugar. Cellulose and hemicellulose, what it will do, its nature is like it will be a polysaccharide, and that polysaccharide can be hydrolyzed into the simplest form of sugar. And the lignin supports the cell structure embedding the cellulose and hemicellulose, and hindering the susceptibility to the microbial attacks during hydrolysis process of anaerobic digestion. Next point is like pretreatment breaks the lignin layer, making the biomass more susceptible to the microbes. Next is the pretreatment also decreases the crystallinity of cellulose and increases the porosity. So the crystallinity of the cellulose, it will be decreases the crystallinity of the cellulose. So you can see that this is the picture of cellulose. Lignins are there and hemicellulose are there. So with the pretreatment process will break down the crystallinity of cellulose. So here you can see that it is like this structure is there. So after pretreatment, the structure will be break down like this. So the crystallinity of cellulose and increases the porosity. So when it will be break down like this, then liquid hydrolysate and solid residue will be there. So liquid will be separated and solid will be separated. So what happened for the food waste, the fruit and vegetable waste, it can be easily degraded but results in a low biogas yield. But it will be results to the low biogas yield due to the presence of inhibitor and necessitating pretreatment. So next is the it will be decreases. This pretreatment will be required to decrease the crystallinity of cellulose. The cellulose crystalline structure will be break down because of this pretreatment process. You can see that this is the picture. Like after breakdown, liquid and solid will be separated. Solid residue will be at one place and liquid residue at one place. So the this will be happen basically for the food waste like fruit and vegetable waste, and can be easily degraded but results in the low biogas yield due to the presence of inhibitor and necessitating pretreatment. So we'll discuss about the sludge biomass. So sludge biomass is those biomass like municipal wastewater treatment sludge during the municipal solid sewage water treatment. So when in sewage water treatment, what happened? Sewage will be treated in a big settling chamber. So in that chamber, what happened? The solid particles, the TDS, the suspended particles are there into the water that will be going to be settled down, and the water will be coming out from this. So with the settling of these solids, will leads toward the production of sludge. So municipal waste treatment sludge, you can see that this is the sludge. That sludge will be obtained after the municipal wastewater treatment. This is the industrial sludge, and sludge from various type of processing industries like food processing. So food processing industry is there, some many industries is there. The sludge, these are the example of the some of the sludge that will obtain from the many different sectors. This is will like by sewage treatment process. Sewage treatment process. Next is the industrial wastewater treatment process. Next is the sludge from various processing industry, like processing industry will dairy processing industry or some tanning industry. So all are producing some of the amount of sludge. That sludge is nothing but a solid settles are there, suspended solution are there, so suspended solid materials are there, that is called as sludge. So for this sludge biomass also pretreatment will be required. So what are the effects of pretreatment of sludge biomass? So what happen when we'll do the pretreatment of this sludge biomass? So sludge biomass of wastewater treatment has very high organic content, because this is all are in organic nature, because soil are there. So the sludge biomass of wastewater treatment are having high organic content. Secondary wastewater sludge consists of numerous microbial cells, and walls of this cell act as a barrier against exoenzyme degradation. So the secondary wastewater sludge consists of numerous microbial cell. Like this secondary wastewater sludge will be having many microbial cells, and the walls of these cells act as a barrier against exoenzyme degradation. In activated sludge, the flock structure will be there. In activated sludge condition, flock structure will be there, like exocellular polymeric substances, EPS. This will be comprises of major organic fraction and binding mechanism for EPS, exocellular polymeric substrate, to a cations. This will happens to be a significant factor determining the digestibility of activated sludge. In activated sludge process, flock structure will be formed and exocellular polymeric substance are there. These EPS will comprises a organic fraction and binding mechanism of EPS to a cations happens to be a significant factor for the determining the digestibility of activated sludge. So therefore what happened, the hydrolysis steps become rate limiting and degree of degradation is limited. So the degree of degradation is limited like 30 to 35 degrees Celsius. And the COD reduction in conventional anaerobic sludge treatment will be there. So the hydrolysis steps become rate limiting and the degree of degradation is limited. So the degree of degradation is also limited, and the hydrolysis steps will lead toward the limiting of these steps, and the 30 to 35% of COD, chemical oxygen demand reduction, in conventional anaerobic sludge treatment will be there. So these are the effects of the pre-treatment of the sludge biomass. Sludge biomass should also go for the pre-treatment, and that will be having, because of the reason this sludge will be having very high organic matter, organic load. So the secondary wastewater sludge consists of the many microbial cells, and the walls of these cells act as a barrier against the exoenzyme degradation. For the enzymatic degradation, the microbial cells wall will be act as a barrier. So in activated sludge flock structure, so after this activated sludge process method, the activated sludge will be there. So flock structure will be created. That flock structure is a exocellular polymeric substances that is comprises of major organic fraction and binding mechanism of EPS to cations happens to be a significant factor determining the digestibility of activated sludge. So that we can see that the hydrolysis steps become rate limiting and the degree of degradation is limited, like 30 to 35 degrees Celsius, 30 to 35% of COD reduction in conventional anaerobic sludge treatment process. You can see that this is the pre-treatment of sludge. Pre-treatment of sludge is like that what we are discussing. After this activated sludge process, extracellular polymeric substance will be there. You can see that these are the some structure of this ESP, extracellular polymeric substance. So when the AOP will begin the addition of Fenton reagent, we are adding Fenton reagent in the process, and that because of this Fenton reagents, deflocculation occurs. Deflocculation occurs, and that will leads to the ultrasonic process, and cell lysis occur. So in the Fenton process, Fenton reagent will be added, and this Fenton reagent will break down the flux, and in this way deflocculation occur. So flux will be break down and deflocculation will occur. And next what happen? Ultrasonic process will be there. This ultrasonic process will break down the cells, that is called as cell lysis occurs. So this picture represents the pre-treatment of sludge ruptures of cell wall of sludge floc structure, like biomass pre-treatment for enhancement of biogas and facilitates release of intracellular matters into aqueous phase, like production, anaerobic digestion, and these are the improving biodegradability with lower retention time and high biogas yield. So these are the pre-treatment of sludge biomass. So for the sludge biomass, we'll add Fenton reagent. This Fenton reagent will causing the deflocculation, means the flocculation will be breakdown. This is called as deflocculation. So deflocculation will be like some ultrasonication process will be there, and that ultrasonication process will break down the cell. This is called as cell lysis. Then next we'll discuss about the non-conventional biomass. So non-conventional biomass are those biomass like algae. So algae are capable of using sunlight and carbon dioxide and produces protein, carbohydrate and lipid through the photosynthesis process. Microalgae biomass supports higher photosynthetic efficiency, higher biomass yield and higher CO2 fixation than higher plants. That's why this microalgae is very important. This microalgae will support some higher photosynthesis efficiency, higher biomass yield and higher CO2 fixation than higher plants. Then biogas production has been considered the simplest bioconversion process to obtain energy from the microalgae. So this biogas production is like it will be the simplest bioconversion process to obtain energy from the microalgae. And the effects of pre-treatment of microalgal. So the what happened for this pre-treatment for this microalgae? The microalgal cell envelopes is made up of thick and hard layer composed of complex proteins and carbohydrate with more mechanical power and high chemical resistance, restricting the attack of biopolymer by methanogenic bacteria during anaerobic digestion. You can see this is the picture of this pre-treatment of microalgal biomass. The microalgal cell envelopes is made up of, this cell envelope is made up of thick and hard layer of composed of organic complex protein and carbohydrate. Very hard layer of protein and carbohydrate with more mechanical power and high chemical resistance. High chemical resistance will be restricting the attack of biopolymer by methanogenic bacteria during anaerobic digestion. You can see that this is the picture, like some rigid algal cell wall before pre-treatment, and it will be leads toward the stator will be there, shear gap will be there, rotor will be there, and then the cell wall collapse after the pre-treatment. The cell wall will be break down. This cell envelope will be break down after this mechanical power and high chemical resistance, restricting the attack of biopolymer by methanogenic bacteria during anaerobic digestion. So what happened? Why this pre-treatment is required for this microalgal biomass? What are the effects of this pre-treatment on the microalgal biomass? So pre-treatment improves the liquefaction process by biopolymer release and enhancement and leads to solubilization of the organic fraction. Pre-treatment methods increases the biogas yield, and next is the pre-treatment should be carried out at a mild condition to prevent excessive sugar degradation. So three important points are there that will be required for the pre-treatment of microalgal biomass. Pre-treatment is going to improve the liquefaction process by biopolymer release enhancement and leads to solubilization of organic fraction. Pre-treatment methods increases the biogas yield. Pretreatment should be carried out at a very mild or low condition, basically to prevent excessive sugar degradation. So these are the effects of pretreatment of microalgae. Like microalgae is a non-conventional biomass, so this pretreatment will improve its liquefaction process. By some biopolymer will be released, and that biopolymer will enhance and leads to the solubilization of organic fraction. So this biopolymer will enhance and it will leads toward the solubilization of organic fraction. Pretreatment should increases the biogas yield. It will basically increases the yield of the biogas, and pretreatment should be carried out at mild condition to prevent excessive sugar degradation. So these are about the effects of pretreatment on the microalgal biomass. Now these are my references. These are some of the references of some of the textbook that I have used for this lecture. You can also go for the in depth if you want to do study about this pretreatment process and anaerobic digestion process. You will go and you will find some depth knowledge about this topic. So now I am concluding my lecture. So in this lecture, I have discussed you about the requirement of this pretreatment of this live feedstock, either for energy crop or for some sludge methods or for some sewage wastewater sludge or some algae or some microalgae. So why this pretreatment will be required? So this pretreatment will helps in enhancement of this biogas production or the methane production. So if we will done the pretreatment before of the substrate before entering into the digestion chamber, then the will leads to the proper best development of the methane production. It will leads to the best development of biogas. So thank you for today's lecture. If you have any comment, if you have any doubt regarding this lecture, you will write in the comment box, or you can directly mail me on my mail ID, that is shikha.pandey@gmail.com. So you will write on this mail ID. Thank you for today's lecture.
Like, share and subscribe. Hit the bell icon for more updates.